All right, what's going on, guys? I apologize for Monday. We're going to go over what we are going to go over on Monday, okay? So that would be, let's see, questions 1 to 20 on page 326, right? So we're just going to go over this. Some of it, basically, I'm just going to give the answers. The other ones that we got to kind of talk about, make some diagrams, right? So for number one, it says the graph below is a computer-generated forecast of air temperature and dew point for a city during a period of 2.25 days. So they give you air temperature and dew point. So at what time during this period would the rate of evaporation expected to be the highest? So what you have to do is you have to find where the air temperature is the warmest, okay? So on the diagram, it has the temperature in Fahrenheit, okay? So it gives you the top line is air temperature. So all you have to do is you have to find where that basically squiggly line that they give you, where it's at the highest point. So for this squiggly line that I made, okay, if I make it a little bit more for now, that's going to be the highest point with temperature, okay? So if we now follow this down, it is going to give you the date and the time. All right. So for that, the date and the time, it's going to be April 27th. And the time, it's going to be 10 a.m. Okay. So that's going to be choice number one. So I'm going to, let's see right over here. So number one is 1. Okay. Again, remember, the warmer it is, the greater the chance of evaporation. Okay. It just makes sense. When it's a hot day, everything's going to evaporate a lot faster than if it's a cold day. Okay. Especially think about it after a rainstorm. Okay. If it's a really hot day, those puddles, the grass is going to dry a lot faster than if it's a cloudy day and it's cold. All right. So number 2, what is the general pattern of air temperature on March 21st at Earth's equator at 0 degrees? So for this, we have to look at March 21st, okay? And when we're looking at the equator. So what you could do also is you could look at your reference table. So the 2 pages that we've been really working on in our reference table, or at least a couple of pages. So Earth Science Reference Table, we have been hanging out at page 12 to page 14. All right. So if we look at the equator at 0 degrees, you will notice that a lot of the wind, the planetary winds, are going into the equator, okay? Because of that, since they're going in, there's nowhere for it to go, okay? They're crashing into each other, and if this is basically the ground, which I'm going to make green, the wind cannot go down into the ground. It can only go up, all right? So that's going to give us one of the clues. So we're looking at choice 1 and 2 for upward, okay? Now, the other thing is, when we think of the equator, we think of warm temperature. So it's going to be a high temperature. So right now, we're looking at number 2, choice 2. It says upward due to high temperature. And what do we know about high pressure systems and low pressure systems? High pressure systems, all the wind is going out in a clockwise rotation. A low pressure system, they're all going into it because it's a low pressure system, all right? So if we look at the reference table and we look at the equator again, we'll notice that all the wind is going into the equator. So that's going to show us that it's a low pressure system there and the wind is going into it, okay? So that's going to give us choice number 2. It's going upward due to high temperature because it's at the equator, and it's a low pressure system because all that wind is going into it. Remember, low pressure system, all the wind goes into it. So number 2 is going to be 2. All right, so let me make some room for the next stuff. All right, so now, number 3, as the amount of moisture in the air increases, the atmospheric pressure will probably. So here's another one that we can use right from the reference table. So if you go to the top of page 14, okay, you have everything to do with the layers of the atmosphere, okay? So remember, we're in the troposphere. So we're just going to look at the troposphere right now. If we look at the troposphere and we follow it across, remember the first part is all about temperature. Then we have pressure. Then we have concentration, which is water vapor. If we look at pressure, as we go up, it's showing that pressure is decreasing with altitude, okay? This is if you ever go up into upstate New York and you're going up a hill or a mountain, you usually feel your ears pop. The same thing happens when you're in an airplane, okay? When you're going up during liftoff and then when you're descending. That's why it's a good idea to chew gum when you're on an airplane. This way, your ears don't pop. So for number 3, as the amount of moisture in the air increases, the atmospheric pressure will probably decrease, which is going to be number 1. So 3 is 1, okay? Number 4, according to the Earth Science Reference Table, as air pressure of 29.65 inches from mercury is equal to. So again, this is another Earth Science Reference Table question. You go right into this, but this time we're going to be going to page 13, okay? So page 13, we have to find this chart, which is our pressure chart. We're going to go to inches, okay? Remember, it's millibars and inches. So we're going to look at the inches side. We're going to go to 29.65, which is over around here. And we're going to follow that across, okay? And when you follow that across, you are going to get let's see, I'll do it right now. I'm going to get 1004.0. And remember, we always got to put the units, so it's going to be millibars, okay? That's what we're going to go over from inches. So for that choice, it's going to be number 4. So 4 is 4. All right. Which factor is most directly related to wind velocity? So wind velocity. This is when we look at, when we did in quarter 1, our topographic maps, okay? Remember, when we were looking at those mountains, right? And those different landforms, we were getting stuff when we were looking at the contour lines, okay? Where it was stuff like this, okay? Now, remember, in respect to topographic maps, if I asked you, okay, if this is the top of the mountain, and we're looking at where the greatest gradient is, it's where those lines are close together, okay? So right here, this would be a steep side where this would be a gradual slope going down the mountain. So it's the same thing with wind, okay? When you're looking at a map from above and it has the different velocities of wind, if you're looking at the top and these different wind patterns, okay, are close together, that's going to be a stronger wind. So it's going to be a greater pressure gradient, okay? Because you're going always from high temperature or high pressure to low pressure, okay? Remember, wind's always going from high to low. So if they're close together, All right, those lines, it's going to be a faster pressure gradient. So for number 5, it's going to be choice 2, pressure gradient. Number 6, 2 weather stations are located near each other. The air pressure at each station is changing so that the difference between the pressure is increasing. The wind speed between these two locations will probably. So again, looking at this, right? If you have 2 stations and the pressure between them is increasing, okay, the wind speed is also going to increase. So for number 6, the wind speed is also going to increase. And that is going to be choice number 2. All right. Okay. So the reason why I did this picture is because it brings us to number 7. So the diagram below shows the isolines. Okay. So remember, isolines, those are the same thing as topographic map lines. All right. Contour lines. But instead for isolines, we're talking about pressure. Okay. So the diagram below shows isolines. So instead of being contour lines, now we're changing these to isolines. All right. And instead of the top of my mountain, they tell us that this is low. Okay. So this is a low pressure system. On which side of the low pressure center will the wind speed be the greatest? So same thing. We're looking for isolines that are close together. So for this case, it's going to be on this side. Now, we don't know what direction that is. But since we're looking at a picture, okay, we're always going to make our compass, which they included for you. Remember, the top is always north, the bottom south, and then you have west, and then you have east, unless they tell you otherwise, okay? But for this, they give you the compass, and they put it right next to it. So all you have to do is you have to find which side from the low pressure system these iso lines are close together. So it's going to be east because we're going that way. So for number 7, it's going to be 3. Number 8, which statement best explains why the air pressure is usually greater over the ocean than over the land during the daytime hours of the summer? So let's get rid of this. All right. And we're going to make some water. We got our lands, okay? And we're going to talk about basically what heats up more, okay? If you ever open up the pool over the summer, it usually takes a while for the water to get heated up, okay? So what happens is during the summer, right, you got the sun going over it. Which one's going to heat up more? Your land is going to heat up a lot faster during the daytime than it is over the ocean, okay? And because of that, air pressure is lower over the ocean. That's why if you go to the beach, it's always a lot cooler in the ocean than it is on land, okay? Forgetting what happens with wind, okay? So for this, for number 8, it's going to be air temperature is lower over the ocean. So that's going to be number 1. Number 9, planetary winds do not blow directly north and south because of. So if you did the reading, and we're going to get more into this when we get into astronomy, when we're looking at space and stuff and how the Earth is rotating. That's going to be the next topic after this. But the Coriolis effect is the reason why our wind does not go from north to south perfectly, okay? And you'll see that if you go to page 14 in your reference table, okay? Right here, you have your Earth. And if you look at all the different wind directions, it's telling you which way they are going, okay? So for us, if we're talking about ours, right, we're around 40, 41 degrees latitude. We always have a southwest wind, okay? That's usually coming up. So in that case, for this, the reason behind all that change in direction is the Coriolis effect. So number 9 is going to be 1. All right, number 10. So a barometer indicates a pressure of 30 inches mercury at sea level, okay, at 3.5 miles above sea level. It indicates the pressure of 15 inches. What is the best conclusion to be drawn from this data? All right. So for number 10, it's going to be of the total mass of air, about 50% is more than 3.25 miles above sea level. So number 10 is going to be 4. Number 11, which diagram best shows the relationship between atmospheric pressure and water vapor content on Earth's surface? So we have basically a bunch of graphs, okay? So it's showing pressure going up, and then it's showing water vapor content. And we have to figure out which graph is the right graph in respect to this, okay? So again, we're going to look at this. We got pressure. Now, this shows that pressure, as altitude goes up, it decreases. But we're going to look at what happens when pressure goes up. So there's a lot of pressure in the troposphere, okay? So as pressure goes up, right, because we have a lot of pressure on top of us because we're at sea level. We're not high up in altitude. What's going to happen to our water content? So if we also look at that, it also shows that when there's a lot of pressure, there's a lot of water vapor. So we have to look at which line shows that as pressure goes, water vapor, and it's going to be going this way, okay? So it's going to be 11 is going to be 4. How are you? I just saw your comment. Number 12, according to the Earth Science Reference Table, which diagram best represents the relationship between altitude and pressure? Okay, so again, we're going to look at this. It's showing that as altitude goes up, pressure decreases. So number 12, we have to look for a chart that shows pressure going down in respect to altitude. So for number 12, it's going to be number 3, okay? So if we go, it's going down like this, okay? Wind moves from regions of, so we always got to know this. Wind always moves from high to low. So 13 is going to be 2. Number 14. So base your answers to questions 14 to 17 on your knowledge of earth science in the diagram below. All right. So they give you a diagram that basically corresponds to page 14 with this chart. Okay. So the curving path of the surface winds shown in the diagram are caused by Earth's, and the Coriolis effect, all right, that is caused by Earth's rotation. That was also in the reading, but we're going to explore that more when we get into Earth's movement in space, okay? So it's a little bit before we get into that topic, but since it was in the reading, just know that rotation is the reason why wind doesn't go in a straight line, okay? So 14 is going to be 3, rotation. Which location might be in New York State? So again, we're looking at New York State, okay? Where we live, we're around 40 to 41 degrees on our latitude, okay? So if we're looking at our chart, right, whether you use the reference table or if you actually use the book, all right, it has the letters inside of it. So we have to find which letter falls in between or near 40 degrees. So if you look at choice B, it's between 60 and 30 degrees, and it's the only letter in that spot. So because of that, 15 is going to be choice B, which is number 2. Which location is experiencing a southwest planetary wind? So it's not in the book. We have to look at our reference table. We have to find which one of those letters is experiencing a southwest wind. So if we look at choice number letter A, all right, letter A is all the way up at the North Pole. If we look at that, it's experiencing a northeast wind. So we got to cancel that out, okay? Because if we look up at the top, it tells us northeast wind. Now, if we go to B, which we just did before, we'll see that it's experiencing a southwest wind. So right now, that looks like it's the choice, but let's go on. Let's look at C. We go down. C is getting a northwest wind, but it's on the southern hemisphere, okay? And then our last one, F, is located right on the line. So it's actually experiencing no wind, okay? So for that choice, it's going to be B again. So number 16 is going to be 2. All right. 17. Which location is near the center of a low pressure belt where daily rain are common? So for this, we have to find which letter has wind going into it. Because remember, high pressure is dry. And then a low pressure system, right? That's low and lousy. So you're going to get wet. So if we look at this, we got to find which letter has air going into it to make a low pressure system, okay? Because remember, high pressure, it's always going out. And then low pressure, it's always going in, okay? And just to go over it again, remember, high pressure, the clock is high on the wall. Clocks always go clockwise. So those arrows are going out clockwise. Low pressure, they're going counterclockwise. So if you do it perfectly, your wind is going to come out of a high pressure system clockwise, and then it's going to go into a low pressure system counterclockwise. So for this, we're finding a letter where all the arrows are going into it. And the only one that works for number 17 is letter E, which is number 1, okay? Because on that chart, letter E is at 0 degrees latitude, which is the equator. Number 18, which natural process tends to aid in the cleaning of the atmosphere? So this is when we talk about our acid rain, okay? Basically, evaporation, that brings stuff into the atmosphere. Expansion, okay, it's still in the atmosphere. And transpiration, that's also moisture from trees going up into the atmosphere. The only one that is getting out particles from the atmosphere is when it rains and it picks up those particles and brings it back down to the earth. So precipitation, okay? So that's going to be choice 2. Remember, precipitation could be anything. It could be snow, sleet, hail, and rain, okay? Looks like I got Miss Citadino calling me right now. I'll have to call her back after this. All right, number 19. The ability of sunlight to pass through Earth's atmosphere would normally increase, okay? So remember, we're looking at sunlight. So if we have the sun, and then let's say we have all these dust particles, okay? It could be anything. It could be pollution, all right? It could be just regular dust, all right? What's going to get all this dust out of the air and allow more sunlight to go in, okay? So if we look at it for number 19, after a period of volcanic activity, when we're doing plate tectonics with the volcanoes, remember, if it shoots up into the air, that's going to be a lot of dust blocking out the sun. So it can't be number 1. After a period of precipitation. So if we have a cloud and then it gets brought down and it gets brought down to Earth, okay, that's getting out some of those cloud particles. So that looks like it's the choice right now. During cloud formation, if you have a bunch of clouds, Okay, that's going to be a cloudy day, so sunlight's not going to be coming through. And then during a period of atmospheric pollution, if you put more pollution up into the atmosphere, okay, basically it's going to be blocking out the sun. So the only choice is going to be after a period of precipitation, okay? So number 19 is going to be 2. And then our last one, which diagram best represents the relationship between the number of dust particles in the atmosphere and the atmospheric transparency, okay? So basically, it's if you can see through the atmosphere. So if you have a lot of dust particles in the air, you're not going to be able to see, okay? That's like places where you get that haze, like everything that's happening in the world right now, where a lot of factories are shutting down. If you actually look at maps from space, you can actually see that the amount of dust particles, okay, and has gone down tremendously because there's no more factories pumping up all that toxic pollution, okay? So again, we have a graph and we have the number of dust particles. And then let's see, what is it saying? Oh, transparency, okay? So in order for the transparency to go up, okay, the dust particles have to go down. So it's going to be something like this. So that's going to be choice number 1, okay? So that is basically all the answers for this set of questions, okay? I know I went a little bit longer than I was supposed to, but I wanted to explain all of them. Hopefully I did. I know that it's a little bit different learning from this than in the classroom where you can ask me questions right when they happen, okay? So basically all I want to talk about is the homework. So this was due on Monday, but I didn't see a lot of people doing it. So remember, try to get done with the air fronts and air masses, and we'll go over that on Friday, okay? And then the new thing I'm going to give you guys is basically a little bit more of the reading, okay? I know it's kind of boring how we're doing this right now, but this is the best that we can do. I'm going to put another video online so you guys can watch that. Hopefully it helps you with the questions. But we're going to do page 334 to 339. And I will also, after this, post up the actual pictures of the textbook in case people don't have them, okay? And remember, a lot of the questions, Earth Science Reference Table, they're page 12 to 14. That's what we're really focusing on for this, okay? That's pretty much all we got today. I hope you guys are doing well. And stay safe. If you have any questions, email me, write me a comment on Google Classroom. All right. And then we're just going to slowly truck through this stuff. Okay. All right. I'll see you guys later.